Hello everyone, welcome to ODIA IITian. In this video lecture, we will discuss optical mineralogy and numericals related to it, which are asking in the iitjam and get entrance frequently. The first topic is optical indicatrix. An anisotropic mineral, the refractive index varies with crystallographic direction. We know refractive index of E ray varies from omega to epsilon that we studied in the previous lecture. Similarly, the relationship can be illustrated with the help of geometrical figure known as optical indicatrix. Optical indicatrix of an anisotropic crystal is an ellipsoidal whose semi-axis is proportional to refractive index. Note, in the crystal of cubic system, which is also called isometric system, the refractive index in all direction is same, so that in this case sphere is for uniaxial indicatrix. In tetragonal and hexagonal system having two value of refractive index, first for vibrating parallel to c-axis, second for vibrating normal to c-axis. Normal to circular section is called semi-axis. The length of semi-axis may be greater or may be small than the radius of circular section. We can see here that the length of semi-axis is greater than the radius of circular section. If the length of semi-axis may be greater than the radius of circular section, the ellipsoid will be prolate and the crystal is optically positive. We can see here that the semi-axis length is greater than the radius of circular section. In this case, it is prolate and positive. We can also distinguish by the refractive index of E ray is greater than the refractive index of O ray, and also the length of semi-axis is vertical, so it is prolate positive. If the length of semi-axis is less than radius of circular section, the ellipsoid is oblate, the crystal is optically negative. Here in this case this is oblate. In this case refractive index of E ray is less than the refractive index of O ray. The length of semi-axis is horizontal, so it is oblate negative. We now some important notes. Semi-axis is normal to circular section. Optic axis is normal to optic axial plane and basal section. When c-axis is horizontal, bireference is maximum. When c-axis is vertical, bireference is 0. Now, biaxial indicatrix. In biaxial crystal, the optical indicatrix is a triaxial ellipsoid. In the length of its three semi-axes are proportional to refractive index alpha, which represent to x-axis, beta, which represent to y-axis, gamma, which represent to z-axis. This triaxial ellipsoid has two circular sections having diameter equal to intermediate axis. As there are two optic axial crystal of the group is called biaxial. In this case, you can see this is the first circular section and this is the second circular section. In this case, y is normal to xz plane. This is the z-axis direction. This is the x-axis direction, and this is the y-axis direction respectively. Now, three principal sections throw the indicatrix along the plane xz, xy, yz and xz plane. Out of these three sections, xz section is the important. The length of semi-major axis, which is c-axis, that is gamma, which is the refractive index of c-axis. Similarly, semi-minor axis, the x-axis, which represent the refractive index alpha, axis of xz proportional. Intermediate refractive index is beta, which represent to y-axis. Now the important part, if z-axis is the acute bisectrix, then it will be known as positive crystal. If x-axis is the acute bisectrix, then it will be known as negative crystal. So in this case, this is the z-axis direction and this is the 2B angle. So in this case, this is Z acute bisectrix. The mineral is positive in nature. Similarly, another one. In this case, this is the x-axis direction. This is the z-axis direction. In this case, 2b angle is the acute angle with respect to x-axis. So this is the mineral is negative in nature. This is an important formula which we are going to use for solving numericals. That is known negative omega more than epsilon. In the given numerical, the retardation of a uniaxial negative mineral of thickness 0.03 micrometer is 5160 nanometer in its principal section of indicator. If the refractive index of corresponding to E ray is 1.486, the value of refractive index of the O ray is dash. आंसर पूछा गया हमको 3 decimal places में. So in this case हमको बोला है कि uniaxial negative mineral according to the formula that is known NOMe. So in this case negative mineral when omega is greater than epsilon, the mineral is negative. So in this case given here the thickness is 0.03 micrometer. In this case हमको micrometer को nanometer में convert करना है क्योंकि retardation का value हमको nanometer में दिया गया है. So in this case the retardation is 5160 nanometer and the refractive index of E ray is 1.486. यहाँ पे according to known formula ओमेगा का रिफ्रैक्टिव ओ रे का रिफ्रैक्टिव इंडेक्स ऑलवेज ग्रेटर देन रिफ्रैक्टिव इंडेक्स ऑफ ओ रे फॉर यूनिएक्सियल नेगेटिव मिनरल. सो इन दिस केस वी नो द फॉर्मूला रिटार्डेशन इक्वल टू थिकनेस इनटू बायरेफ्रिजरेंस. सो हमको पता है बायरेफ्रिजरेंस का फॉर्मूला मैक्सिमम रिफ्रैक्टिव इंडेक्स माइनस मिनिमम रिफ्रैक्टिव इंडेक्स इनटू थिकनेस हमको गिवन दिया गया है इक्वल टू रिटार्डेशन. सो इन दिस केस the refractive index of O ray equal to 1.658. Next question. The speed of light in an unknown medium is measured to be 2.7 into 10 to the power 8 meter per second. What is the refractive index of the second medium? So in this case refractive index equal to C by V. Velocity in vacuum divided by velocity in medium. In this case हमको पता है universal 3 into 10 to the power 8 meter per second is the velocity of light in vacuum. यहाँ पे given दिया है 2.7 into 10 to the power 8 meter per second with the velocity of light in a medium. So the refractive index is 1.11. Next, moving to the important topic pleochroism. It is the ability of a mineral to show different color when viewed along different crystallographic orientation due to the unequal absorption of light. It is the quantitative and qualitative color change due to rotation of the microscopic stage. Pleochroism mineral of tetragonal, hexagonal and trigonal system shows two specific absorption color, that is dichroism, parallel to vibration direction of E ray and O ray. Biaxial crystal have three principal vibration direction, that is X, Y and Z. Along this direction, three distinguished color can be observed. The greater the difference between the indices of refraction, the more intense and are the interference color is produced. In this case, tourmaline is a dichroism mineral. In this case, we can see at 0 degree, 180 degree, it's the maximum color, and at 90 degree and 270 degree is so the light color. This is the quantitative and qualitative color change by rotating the microscopic stage. This is one of the important. आपको ये याद रखना है इसमें सीक्वेंस फ्रॉम लोअर एनर्जी टू हायर एनर्जी किसका वेवलेंथ सबसे ज़्यादा है एंड किसका फ्रीक्वेंसी सबसे ज़्यादा है, ये आपको सीक्वेंस में याद रखना है. If you want the notes, then join our Telegram group ODIA IITian. Link is given below. Thank you for watching this video lecture. If this lecture is informative to you, please like, share and subscribe. Thank you.